In mathematics, integration is a method of adding different parts of a function to find the whole. It is opposite process of differentiation. Implies integration is opposite of differentiation and differentiation is opposite of integration. Integration can be studied in two ways. One, indefinite integration. Two, definite integration. In part 1, I am going to cover indefinite integration. This is a symbol of integration. First we write integration symbol, then we write the function. Example, if it is sin x, we write the function. So sin x is a function here with respect to x. This dx stand for with respect to x. That means it is dx is not multiplied to sin x. Sin x operation depends upon x. Therefore we do write dx, that is with respect to x. The entire function, the total entire operation of the function depends upon variable x. So therefore with respect to x. Similarly, integration of sin y with respect to y. Similarly, integration of tan z with respect to z. So here the variable is y. In the second example, variable is y, therefore stand for with respect to y. In the third example, the variable is z, therefore it is with respect to z. So integration of sin x with respect to x, integration of sin y with respect to y, integration of tan z with respect to z. So we do speak integration symbol first, then we speak the function second, and after that with respect to the, that is a dz, dx, dy, etc. Now let us do some set of problems. I have divided this set of problems in terms of different types. I request the student to do the problems along with me, and when I do these problems you might be feeling easy, but when you try to do alone you might be not able to do all the steps. But practice makes perfect, so I request you to have a pen and paper and do along with me. So let's start the set of problems in integration. Consider type 1. In type 1 problem, I am going to consider this type, integration of x raised to n with respect to x equals to x raised to n plus 1 upon n plus 1 plus c. In indefinite integration, we do write plus c because we do consider the results of integrations are not perfect. To make them perfect, we do write plus c. Now in this type, I am going to do the problems which are having the power n, and this is called standard form. It is called standard form. Standard form means if it is having 2x plus 1 raised to 5, I do say it is not a standard form because it is a combination of more than one element. That is that 2 is also there, x is also there, plus 1 is also there. So it is not standard form. Standard form is having single variable. That is that x is a single variable having the index n. So I am going to consider this type of problem in the type 1. While solving integration problems, if the function is not in the standard form, first we convert the given problem to standard form by putting k, u, v, z, etc. Let's see some examples. Example, integration of x raised to 5 upon 2 with respect to x equals to how much? Here x raised to 5 by 2 dx can be compared with x raised to n dx, that is n equals to 5 upon 2. Since integration of x raised to n with respect to x equals to x raised to n plus 1 upon n plus 1. Therefore, integration of x raised to 5 upon 2 with respect to x equals to x raised to 5 upon 2 plus 1 upon 5 by 2 plus 1 equals to x raised to 7 upon 2 divided by 7 upon 2, that gets reversed, 2 upon 7 x raised to 7 upon 2. Of course, the plus c has to be written because it is indefinite integration. In this example, integration of 1 upon x raised to 7 with respect to x, this can be written as x raised to minus 7 with respect to x, because we know the algebraic identity 1 upon a raised to m is equals to a raised to minus m. Therefore, 1 upon x raised to 7 can be written as x raised to minus 7 with respect to x equals to x raised to minus 7 plus 1 upon minus 7 plus 1, because formula of x raised to n, integration x raised to n with respect to x equals to x raised to n plus 1 upon n plus 1. By using that formula, it becomes x raised to minus 6 upon minus 6. Of course, this minus will go to numerator, so minus x raised to minus 6 upon 6, a raised to minus m equals to 1 upon a raised to m. Therefore, it becomes minus 1 upon 6 x raised to into 1 upon x raised to 6 plus c. So, this is the final answer of this one. Therefore, 1 upon x raised to 7, integration of 1 upon x raised to 7 with respect to x is equal to minus 1 upon 6 x raised to 6 plus c is the answer. Another example, integration of 2x plus 1 whole square dx. This can be done in two ways without putting k, u, etc. And first method is direct expansion, that is a plus b whole square formula, that equals to a square plus twice ab plus b square. Here, if we use that identity, it becomes 4x square plus 4x plus 1 dx, that is the integration with respect to x. Now, we do individual integration of individual parts, that is integration of 4x square with respect to x, integration of 4x with respect to x, and integration of 1 with respect to x. Whenever the constants are there, we do take outside operation, that is 4 into integration of x square dx. They are multipliers, and integration here the 4 is taken outside, x dx, and it is a 1 dx. So what we can do now here individual integration, x square integration is x raised to 2 plus 1 upon 2 plus 1, and integration of x is x raised to 1 plus 1 upon 1 plus 1, and integration of 1 is x. Integration of 1 is x. Please note down that. Now here is a 4 x cube by 3 plus 4 x square by 2 and plus x. If cancellation possible, you can cancel them. Here 2 1s are 2 2s, I have cancelled them. Wherever cancellation not possible, keep as it is. So I got here 4x cube upon 3 plus 2x square plus x plus c. Therefore, integration of 2x plus 1 whole square dx equals to 4x cube upon 3 plus 2x square plus x plus c. This is required answer. This is by expansion method. The same problem we can do by substitution method as well as. Now, same problem can be done by substitution method. Let us see here. The given problem is not in the standard form. To convert into standard form, let 2x plus 1 equals to k. You can put u as well as v, z, depending upon your college teacher. So I like k, so I put k always. So 2x plus 1 equals to k. And now, as soon as you put k, to convert into the standard form, we do derivative, differentiation of 2x plus 1. with respect to x equals to dk by dx, both side with respect to x, because the variable is x here. So the derivative of 2x is 2 equals to dk by dx. So dx equals to dk by 2. While teaching in the classroom, I call it for fun purpose, I call this method as a change of kingdom method. Change of kingdom, that means the kingdom of x is getting converted to the kingdom of k. So for the fun purpose, I do call it as a change of kingdom method. Here, therefore, I becomes, now the problem was given in terms of x variable. Now it will get converted to the k variable. 2x plus 1 equal to k. So here the k, the power is as it is, that is square. And after that, we have the dx equivalent to dk by 2. So dx equivalent to dk by 2, I have taken 1 by 2 common, then k square dk. You can observe that how smartly we converted the given problem without expanding it, given problem to the some other standard variable, that is a k. So we converted to not standard form to standard form by putting substitution method. This is the substitution method. Whenever you put k, u, etc., the method is called substitution method. And as soon as you put k, always remember that you must do derivative, differentiation. Now we use the formula here, integration of k square, nothing but k raised to 2 plus 1 upon 2 plus 1, 1 by 2, k raised to 3 upon 3. If they can be multiplied, 2 into 3 is 6. Now here we do back substitution, that is k is nothing but 2x plus 1. So I do write 2x plus 1 whole cube divided by 6, and of course plus c. So this is also the result of integration. Here we have gone through substitution method. Another example, x square into x square plus 1 whole square. We have to do integration. How we can do it? Here direct substitution even are not possible, because substitution will not help us. What we can do, first we expand the bracket here. So that is integration x square. Here we can do the expansion, that is a square plus b square plus twice ab. We can do the expansion, and after the expansion, let us see here, x raised to 4 plus 2x square plus 1. We expanded by using above formula, and after the expansion, even though the two parts are there, we cannot do the integration here because substitution is also not helping us. One idea is that we can multiply x square with every element, then we get the single term everywhere. X raised to 6, 2x raised to 4 plus x square. We open the bracket, multiplying each term by x square, that is here is a x square into x raised to 4 equals to 2 plus 4 equals to x raised to 6, like this each and every term. After that, we can do integration of each and individual term, like integration of x raised to 6 with respect to x, integration of 2x raised to 4 with respect to x, and plus integration of x square with respect to x. After that, the integration of x raised to 6, nothing but using the formula of x raised to n plus 1 upon n plus 1 plus c everywhere. So let's see, x raised to the first term 6 plus 1 upon 6 plus 1, and the second term 2x raised to 4 plus 1 upon 4 plus 1, and the third one x raised to 2 plus 1 upon 2 plus 1. So it becomes x raised to 7 upon 7, and 2 x raised to 5 upon 5, and x cube upon 3. If cancellation not possible, keep them as it is, and at the end you write plus c. Therefore, the integration of this problem is equals to x raised to 7 upon 7 plus 2x raised to 5 upon 5 plus x cube upon 3 plus c. This is required answer. Integration of x raised to 5 plus x raised to 6 plus x raised to 7 plus x cube upon x with respect to x equals to how much? Here, even the direct integration not possible. First, we have to simplify the given expression. We can simplify by splitting into fraction. That is, x will go to each and every term like this. It will get, each and every term will get divided by x. We do call it as a splitting into fraction. When the big fraction given, individual term can be split into fraction. I do call it as a splitting into fraction type. And here each and every term will get divided by x. So I do get here x raised to 4 plus x raised to 5 plus x raised to 6 plus x square integration with respect to x. Here again applying the x raised to n formula, x raised to n integration is nothing but x raised to n plus 1 upon n plus 1. Using that formula each and every place, I do get 4 plus 1 upon 4 plus 1. Here is a x raised to 5 plus 1 upon 5 plus 1, and here x raised to 6 plus 1 upon 6 plus 1, and x raised to 2 plus 1 upon 2 plus 1. So that is equals to x raised to 5 upon 5 plus x raised to 6 upon 6 plus x raised to 7 upon 7 and x cube upon 3. At the end we write plus c here. Some teacher do write the plus c even after doing the very first time plus c. So it's a matter of personal interest, but in most of the book, even the as soon as we do the integration, we do write plus c here. So but my habit to write the plus c at the end. You can write the plus c as soon as you perform the integration process. Under this type, I am going to consider problems like integration of 1 upon x with respect to x equals to log of modulus x to the base e plus c. Now let us solve some problems on the basis of this formula. Consider example integration of 1 upon 2x plus 3 with respect to x. Now how to solve it? For that, 2x plus 3 equals to k. It is not in the standard form. To convert into the standard form, 2x plus 3 equals to k. That is substitution method. As soon as we put k, we have to do derivative, differentiation. So differentiation of 2x plus 3 with respect to x equals to dk by dx. Of course, this is easy method, and rectifying is not required here. Only you must know the basic formula, that is integration of 1 upon x equals to log of modulus x with base e. So if you know that formula, remaining thing not at all to be memorized, not even learned, only they come with the logic here. Now as soon as we do the derivative of 2x equals to 2 equals to dk by dx implies dx equals to dk by 2. Now the given problem we can call it I, and this is equals to 1 and dx equals to dk by 2 equals to 2. Now what we are having? We are having I equals to 2x plus 3. The 2x plus 3 is equals to k. So I am going to put here k. So 1 upon k, and dx. The dx is equivalent to dk by 2. So I am going to use that dk by 2, and 1 by 2 of course is a constant, can be taken out of the operation. So 1 upon k dk. So I am having 1 by 2. Integration of 1 upon k nothing but the log modulus k with base e equals to 1 by 2. Back substitution, k nothing but 2x plus 3, and e of course plus c. and here also plus c. This is what the result. Therefore, the integration of 1 upon 2x plus 3 is nothing but equal to 1 upon 2 log of modulus 2x plus 3 to the base e plus c. Here, I want to clear one thing to my students. Integration of 1 upon x with respect to x equals to log of modulus x to the base e. But what happens if it is not x but if it is x square? Can we apply that formula? If it is a x cube, can I apply that formula? Answer is no. When here 2, 3, 4 any other number is there, you cannot apply above formula. You can apply this formula only if here is a 1. If it is not 1, any other bigger number is there, you cannot use this formula. So what you should do in that case? In that case, you can utilize the formula from the type 1 problem. That is, integration of 1 upon x square can be written as a x raised to minus 2 with respect to x, and it is equivalent to, the integration of this is equivalent to x raised to minus 2 plus 1 minus 2 plus 1 equals to x raised to minus 1 upon minus 1 equals to minus 1 upon x plus c. Similarly, when it is a x cube, even we can write x raised to minus 3 with respect to x, and equals to minus 3 plus 1, formula from the type 1, and equals to x raised to minus 2 upon minus 2 equals to minus 1 upon 2 x square plus c. In this way, you can do this problem. If it is any other number is there, in place of x3, there can be x raised to 10, even x raised to 10, then we can use the type 1 method. And this formula only applicable, 1 upon x formula only applicable when the power is 1. Consider another example. Integration of x square plus x cube plus x raised to 4 upon x raised to 5 with respect to x. This can be written as upon x raised to 5 x cube upon x raised to 5 plus x raised to 4 upon x raised to 5 with respect to x. Then this is equals to x square. X raised to 5 can be written as x square into x cube, and here also it can be written as x square into x cube, and here is a x raised to 4. X raised to 5 can be written as x into x raised to 4, and this get cut down, this and this cut down, and this cut down equals to 1 upon x cube plus 1 upon x square plus 1 upon x with respect to x. Now what we can do here, 1 upon x cube can be written as x raised to minus 3, and 1 upon x square can be written as x raised to minus 2, but 1 upon x cannot be written as a x raised to minus 1. We can keep as it is. I just told you in previous problem, integration of 1 upon x is nothing but log of modulus x here. So this becomes x raised to minus 3, integration now of each and every term, x raised to minus 3, that is a type 1 problem, and here is a x raised to minus 2 plus 1 upon minus 2 plus 1, and integration of 1 upon x is nothing but log of modulus x to the base e plus c. Now we can simplify this term, x raised to minus 2 upon minus 2, x raised to minus 1 upon minus 1, and log of modulus x to the base e plus c. This is equals to minus 1 upon 2x square minus 1 upon x plus log of modulus x to the base e plus c. Another example, integration of 2x plus 3 whole square upon x. First, I equals to, and here is a plus b whole square, that is a plus b whole square equals to a square plus 2ab plus b square. So 4x square plus 12x plus 9 upon x. Now splitting 4x square 12x upon x plus 9 upon x dx. Now here, if any cuttings are possible, cut them. Here is possible. Here 9 upon x as it is, so it is a 4x plus 12 plus 9 upon x with respect to x equals to integration of 4x with respect to x, integration of 12 with respect to x, integration of 9 upon x with respect to x. Now here any constant terms are there, we can take out of the operation. 4, here is a 4 is a constant, here is a 12 is a constant, and here is a 9 is a constant. So first we do take out this constant out of the operation, and so the 4 is taken out of the operation. It is 4 into integration of x dx, and 12 integration of 1 dx, and 9 integration of 1 upon x with respect to x. So 4 integration of x raised to 1 is x raised to 1 plus 1 upon 1 plus 1, and integration of 1 is nothing but with respect to x, nothing but equals to x. So 12 into x plus 9, integration of 1 upon x is nothing but log of modulus x to the base e. So the final answer is 4x square upon 2 plus 12x plus 9 log of modulus x to the base e. If cutting is possible, you can cut them. 2 ones are 2, 2s are cut down. So 2x square plus 12x plus log of modulus x to the base e plus c. This is the result. F of x equals to a raised to x is an example of exponential function where a is any number, but the condition is that a should not be equal to 0 and x is a variable. So f of x is equal to a raised to x is an exponential function. F of x equals to e raised to x is a kind of standard exponential function where e is a transcendental number and the value of e is given by 2.71828. Now consider integration of exponential functions. Now we consider integration of a raised to x with respect to x and integration of e raised to x with respect to x. As I already told you, a is a any number and e is a transcendental number. Now integration of a raised to x is nothing but given by a raised to x upon log a to the base e plus c, and integration of e raised to x is given by e raised to x upon log e to the base e. Here we already know that log e to the base e equals to 1, therefore it becomes e raised to x upon 1 equals to e raised to x. Therefore integration of e raised to x with respect to x equals to e raised to x plus c, and integration of a raised to x with respect to x equals to a raised to x upon log a to the base e plus c. Now consider some examples on the basis of a raised to x and e raised to x. Now integration of 2 raised to x with respect to x. As we know the formula, integration of a raised to x with respect to x equals to a raised to x upon log a to the base e. In this question, a equals to 2. So now what we do, we apply this formula. Integration of 2 raised to x is nothing but 2 raised to x upon log a. A is equals to 2, therefore 2, and base e plus c. Now another problem, 2 raised to x into 3 raised to x into 4 raised to x into 5 raised to x with respect to x here. All are multiplied, therefore, and they are having the common index. Therefore, when they are having common index, we can write like this: 2 into 3 into 4 into 5 whole raised to x with respect to x here. This is equals to integration of 120 raised to x, and comparing 120 raised to x equals to a raised to x implies a equals to 120, and we already know that integration of a raised to x with respect to x equals to a raised to x upon log a to the base e. So this problem becomes 120 raised to x upon log a. A equals to 120, therefore 120, and base e plus c. This is the result of given question. Now consider another example, 2 raised to 5x with respect to x. Now we do observe the 5x is not in the standard form. First we will convert into the standard form by substitution method. So let 5x equals to k. As soon as we go for substitution method, as soon as we put k, we must do the differentiation both side with respect to x. So differentiating 5x with respect to x equals to dk by dx, and differentiation of 5x is 5 equals to dk by dx. Therefore dx equals to dk upon 5. Let us call it as a k. This is a 1 expression in second relation, and given problem I equals to, therefore I becomes I equals to 2, and in place of 5x I can write just k. Converting to the single variable, as I already told you, to convert a given problem into single variable is nothing but called standardization. And when we deal with the problem, first step is always standardizing the given problem. So 2 raised to k is a standard form, and dx is equivalent to dk by 5. So putting that value here, so dk by 5 here, and we do take 1 upon 5 common, and 2 raised to k with respect to k integration 1 upon 5, and 2 raised to k integration is 2 raised to k upon log 2 to the base e, and equals to 1 upon 5, 1 upon 5, and 1 upon log 2 to the base e, and 2 raised to k back substitution. K is nothing but 5 raised to x, and at the end plus c. This is the answer of the given example. Next example, integration of e raised to 12x with respect to x. Same as above, only a little change will be there. Same as above, let 12x equals to k. As soon as you go for k, differentiating both sides with respect to x. Now 12x derivative is 12 dk by dx, therefore dx equivalent. In substitution method, we always find dx equivalent, and given problem equals to I, and let us call it as a equation 1, and this is the expression 2. I becomes e raised to, in place of 12x we can put k here, and in place of dx I can write dk upon 12. Now 1 upon 12 common outside, because it is a constant are taken outside always. 1 upon e raised to 12, e raised to k integration is e raised to k upon 1 and equals to e raised to k upon 12, and back substitution k equals to 12x. K value is 12x, so I am writing here the k value 12x upon 12 plus c. This is the result, this is the answer of given example. In this example, 2 raised to 5x plus e raised to 5x dx, we do observe that at both the places 5x is there, but we try to separate them. 2 raised to 5x with respect to x plus integration of e raised to 5x with respect to x. Here 5x equals to k and differentiation of 5x with respect to x equals to dk by dx. So I get here dx equals to dk upon 5. After that I equals to 2 raised to k dk upon 5 plus e raised to k and dk upon 5. We can do together also, but I know you are beginner. I am trying to strengthen your concepts, therefore I am writing all the steps. Once you understand, you can do even shorter than this. यहाँ पर 1 upon 5 रह गया. Now 2 raised to k integration is 2 raised to k upon log 2 to the base e. 1 upon 5 integration of e raised to k is e raised to k, back substitution 1 upon 5 2 raised to 5x into 1 upon log 2 to the base e plus e raised to 5x upon 5 plus c. This is the result, this is the answer of the given example. Now next example, integration of 2 raised to 5x plus 6 with respect to x. The steps are same as above problems. Let 2x plus 6 equals to k. We do get dx equals to dk upon 2 and I becomes 2 raised to k dk upon 2. Then 1 by 2 common, integration 2 raised to k dk, 1 by 2 2 raised to k upon log 2 to the base e, 1 upon 2 1 upon log 2 to the base e, and back substitution k value is 2x plus 6 plus c. This is the answer of given example. Now next example, integration of e raised to 12x plus 5 with respect to x. Steps are 100% same as previous problem. Let 12x plus 5 equals to k, then we get dx equals to dk upon 12. I becomes integration of e raised to k and dk upon 12. After that 1 upon 12 outside, integration of e raised to k with respect to k, 1 upon 12 e raised to k, integration is e raised to k only. It is a single function in entire integration, that integration of e raised to k is equals to itself. So k value is 12x plus 5 and plus c. Final answer can be written as e raised to 12x plus 5 upon 12 plus c. So this is the solution of given problem. In this type, I am going to consider integration of sin x, integration of cos x, integration of tan x, integration of cot x, integration of sec x, and integration of cosec x. I request the students to do the problems along with me. So be ready with pen and paper. So let's start integration of trigonometric functions. Integration of sin x with respect to x equals to minus cos x plus c, and integration of cos x with respect to x equals to sin x plus c. Now we will consider integration of sin 4x with respect to x, cos 4x with respect to x. I am going to deal both the problems simultaneously to distinguish the procedure and to also know what is the similarity between the procedure. Only the formula is changing, but the almost all the steps are remaining the same. Let us see here. Here is a 4x equals to k because it is not in the standard form. Here also 4x equals to k because it is not in the standard form. Then as soon as you put k, you have to do differentiation. Differentiation of 4x with respect to x equals to dk by dx, and here also differentiation of 4x with respect to x equals to dk by dx. Now differentiation of 4x is 4 equals to dk by dx. Here also 4 equals to dk by dx implies dx equals to dk by 4, that is dx equivalent. Here also dx equals to dk by 4, dx equivalent. Therefore I equals to integration of sin k dk upon 4, and here is also I equals to integration of cos k dk upon 4. We notice that till now the steps are same, only the function is different. Now sin k integration is minus cos k and upon 4, and here is a cos k integration is sin k upon 4, and back substitution minus cos 4x upon 4, and here is sin 4x upon 4. Here also plus c, and here is also plus c. So we do notice that the steps are same, only the formula is changing. This is the way we can perform integration of sin 4x and cos 4x. Similarly with some other number, let us see another example for sin and cos. Now consider another example to find integration of sine of 5x plus 8. How to read this? Sine of, because whenever the bracket is there, we do read of. So sine of 5x plus 8 with respect to x. The steps are usual. Let 5x plus 8 equals to k, because it is not in the standard form. To convert into the standard form, I am putting sin x plus 8 equals to k. As soon as we put k, we must perform differentiation. Differentiating 5x plus 8 with respect to x equals to dk by dx, and differentiation of 5x is 8 and derivative of 8 is 0, equals to dk by dx. Then dx equals to dk upon 5. So we obtain dx equivalent to, and given problem is I equals to, and let us call it as a equation 1, and here I equals to integration of sine, and now 5x plus 8 is equals to k. So I am putting in place of 5x plus 8 I am putting sine k, and in place of the dx I am going to use the equation number 1. So here sine k and dk upon 5, and 1 upon 5 is taken outside, sine k dk, and we do notice that the steps are similar, only the function has become the compound expression. So even in that case we have kept equivalent to k. Now sine k integration is minus cos k, and minus cos k equivalent to 5x plus 8 and upon 5 and plus c. This is the solution of given question. I am having another example. Cos of 7x plus 8. Steps are similar as previous problem. 7x plus 8 equals to k. Differentiating both sides because we gone for substitution. So as soon as we go for substitution we must go for differentiation. So it is a change of kingdom method. 7x plus 0 equals to dk by dx. We get dx equivalent to dk upon 7, expression number 1. Given problem, I equals to cos of k nothing but 7x plus 8. So in place of 7x plus 8 I am writing k, and dx equivalent to dk upon 7. So 1 upon 7 integration of cos k dk, 1 upon 7 cos k nothing but integration of cos k nothing but sin k, back substitution, k is nothing but k equivalent to 7x plus 8. We had kept here 7x plus 8 equals to k. So final answer is sin of 7x plus 8 upon 7 plus c. This is the solution of given question. Another example, sin 7x plus 8 multiply to cos of 7x plus 8. Here sin and cos both are multiplied together. So how to do integration? Let us see now. Step number 1, we know the formula that 2 sin theta into cos theta equals to sin 2 theta. Here we do observe 7x plus 8, both sin and cos bearing 7x plus 8. Therefore we can go for that formula, but there is no 2 is available here. To create the 2, multiplying and dividing by 2 here, because in original formula there is a 2 and in the given question 2 is not there. To create the 2 we are multiplying dividing by 2 here. So sin 7x plus 8 dot cos of 7x plus 8 with respect to x, 1 by 2 of course outside. So I have here 2 sin 7x plus 8 dot cos of 7x plus 8 dx. As per as this formula, 2 sin theta cos theta equals to sin 2 theta. I apply that formula here. So sin 2 theta, that is a 2 into 7x plus 8 dx. Now this is not in the standard form. To convert into the standard form, I am going to use the substitution method. Let 2 7x plus 8 equals to k. Again, whenever put k here, we go for differentiating both sides with respect to x, because given variable is x here. So 2 is a multiplier and derivative of 7 is 7, and 0 equals to dk by dx. So I do get 14 equals to dk by dx. Therefore dx equals to dk upon 14. And now I equivalent to sine k, and dx is equivalent to sine k upon 14. So 1 upon 14 is outside. Sine k, integration of sine k with respect to k equals to 1 upon 14, and sine k integration is minus cos k equals to 1 upon 14, and back substitution, that is putting back the k value. K is nothing but 2 into 7x plus 8, and so final answer minus cos 2 7x plus 8 upon 14 plus c. This is the solution of the given example. Now let us remind the two formulae. The formula of cos 2a equals to 2 cos square a minus 1. Another formula for cos 2a equals to 1 minus 2 sin square a. Now this formula can be converted, and we can remember that cos square a equals to cos 2a plus 1, that is equals to 1 plus cos 2a. Therefore cos square a equals to 1 plus cos 2a upon 2. Similarly from this one I do get here 2 sin square a equals to 1 minus cos 2a. So sin square a equals to 1 minus cos 2a upon 2. Therefore sin square a equals to 1 minus cos 2a upon 2. These are the two formulae I am going to use in the next integration. Now integration of sin square x with respect to x equals to how much? Another example, integration of sin square x with respect to x equals to how much? We know from trigonometry identity sin square x equals to 1 minus cos 2x upon 2. This identity I am going to use here. So sin square, in place of sin square I can write 1 minus cos 2x upon 2 with respect to x. 1 by 2 is outside. Integration of 1 minus cos 2x with respect to x here. Now here I equals to 1 by 2 as it is. Now integration of 1 dx minus integration of cos 2x with respect to x. And I want to here show you shortcut. If integration of cos px is there with respect to x, so it can be written as sin px upon p plus c. So this formula, direct formula, we can use here. Therefore I equals to 1 by 2. Integration of 1 is x, and integration of cos 2x is sin 2x upon 2, and the final answer is x upon 2 minus sin 2x upon 4 plus c. This is the integration of sin square x. Therefore we can write integration of sin square x with respect to x equals to x by 2 minus sin 2x upon 4 plus c. Now next example, integration of cos square 5x with respect to x equals to how much? Let us solve this question. Now we know that it is not in the standard form. To convert into the standard form, 5x equals to k, then differentiating 5x with respect to x equals to dk by dx, 5 equals to dk by dx, and dx equals to dk upon 5. Now I equals to cos square. In place of 5x I can put k, and in place of dx I can put dk upon 5, dx equivalent to dk upon 5, and now I do take the 1 upon 5 common. It is cos square k with respect to k. Now cos square k nothing but cos square k, here trigonometry identity, 1 plus cos 2k upon 2. I already told you integration of sin square, cos square, tan square and cot square direct not possible. We have to convert them, like cos square k can be converted to 1 plus cos 2k upon 2. Now 2 will be outside, 1 upon 5 into 2, 1 plus cos 2k with respect to k here, then it is 1 upon 10, then 1 dk plus integration of cos 2k with respect to k. Now 1 upon 10, integration of 1 is k, and integration of cos 2k is sin 2k upon 2. As I already told you that integration of shortcut of integration of cos px with respect to x is equal to sin px upon p plus c. So this shortcut I had utilized here, that is sin 2k upon 2. It is now opening the bracket, it becomes k upon 10 plus sin 2k upon 2 into 10. So k upon 10 plus sin 2k upon 20, but k equals to 5x we already had assumed during substitution. So back substitution gives us 5x upon 10 plus sin 2 into 5x upon 20 equals to 5x. Here cutting possible, cut it, 5 1s are 5 2s are, so it becomes x upon 2 plus sin 10x upon 20. Here 5 1s are 5 4s are cannot be cancelled. It is a part of this 5 belongs to trigonometry and this 20 belongs to decimal number. Therefore 5 and 20 cannot be cancelled. So we can multiply 5 and 2. So we get here sin 10x upon 20 plus c. This is the answer of that given integration problem. Now we will understand how to find integration of sin cube x and integration of cos cube x. Before going to the integration, let us understand the trigonometric relations for sin cube x and cos cube x. Now consider sin 3x. From trigonometry relations, we know that sin 3x given by 3 sin x minus 4 sin cube x. Now this trigonometric relationship can also be expressed in terms of sin cube x by taking 4 sin cube x to the LHS side and sin 3x to the RHS side. Therefore, what I do get here, 4 sin cube x will come to the LHS and sin 3x will go to the RHS, that is sin 3x. Then sin cube x 4 will go down. Four has gone down. Then either you can keep as it is or you can take it to the individual, that is 3 upon 4 sin x minus sin 3x upon 4. So this relationship we can use while doing integration. Similarly, for cos 3x equals to 4 cos cube x minus 3 cos x. Here also, to get the expression for cos cube x, take cos cube x to the LHS side, or you can take the 3 cos x to the LHS side. By taking the 3 cos x to the LHS side, we will save one step. So 4 cos cube x equals to cos 3x plus 3 cos x. And now cos cube x can be written as 4 will go down. Or you can write 4 to individual terms like cos 3x upon 4 plus 3 upon 4 cos x. So while doing integration for cos cube x, we can use this identity. There is a one more method where directly we can do integration of sin cube x and cos cube x, but I do find out this relationship easier for beginners. Therefore, integration of sin cube x with respect to x equals to integration of 3 upon 4 sin x minus sin 3x upon 4 with respect to x. Similarly, integration of cos cube x with respect to x equals to integration of cos 3x upon 4 plus 3 upon 4 cos x with respect to x. Let's do some example on the basis of these formulae. Now let us do another example to find out integration of sin cube of 5x with respect to x equals to how much. First of all, the given question is not in the standard form. We first convert into the standard form. So 5x equals to k implies dx equals to dk upon 5. This is step number 1. Now I becomes integration of sin cube k with respect to dx equivalent to dk upon 5. So with respect to k and upon 5, 1 upon 5 can be taken outside. So integration of sin cube k with respect to k. Now what is the trigonometry identity? Sin cube x is nothing but 3 upon 4 sin k minus sin 3k upon 4 with respect to k. So 1 upon 5 integration of 3 upon 4 sin k dk, splitting them individually, sin 3k upon 4 with respect to k, 1 upon 5, here 3 by 4 outside, integration sin k with respect to k minus 1 upon 4 integration sin 3k with respect to k. So it becomes 3 upon 20. Integration of sin k is nothing but minus cos k and minus 1 upon 5 into 4. Integration of sin 3k becomes minus cos 3k upon 3. We know the integration formula for sin px dx equals to minus cos px upon p. This is the formula for integration of sin px. So I utilize that formula here. So it becomes minus 3 cos k upon 20 minus 1 upon 20 and minus cos 3k upon 3. Now further opening the bracket, it becomes minus 3 cos k upon 20 and plus cos 3k upon 60. Back substitution, k equals to 5x, k equals to 5x. So putting back that relationship here, it becomes minus 3. So it becomes minus 3 cos 5x upon 20 plus cos 3 5x upon 60 plus c of course here, and minus 3 cos 5x upon 20 plus cos 15x upon 60 plus c. This is answer. Therefore integration of sin cube 5x equals to minus 3 cos 5x upon 20 plus cos 15x upon 60 plus c. Now next example, integration of cos cube 7x with respect to x equals to how much? Let, as usual, it is not in the standard form. To convert into the standard form, 7x equals to k, writing directly dx is equal to dk upon 7. Then I becomes integration of cos cube k with respect to k, that is dx equivalent to dk by 7, 1 upon 7 outside, integration cos cube k with respect to k. Now using the trigonometric relationship, that is the cos cube k can be written as cos 3k upon 4 plus 3 by 4 cos k with respect to k, 1 upon 7. Now splitting, integration cos 3k upon 4 with respect to k plus 1 upon 7 into 3 by 4 cos k with respect to k. This becomes 1 upon 28, integration of cos 3k with respect to k plus 3 upon 28, integration of cos k with respect to k, 1 upon 28, integration of cos 3k nothing but sin 3k upon 3 and cos k integration is sin k plus c. Putting back k equals to 7x. Now 28 3s are 3 8s are 24 to 6 8 84. So 1 upon 84 sin 3k, k equals to 7x plus 3 upon 28 sin 7x. It becomes 1 upon 84 sin 21x plus 3 sin 7x upon 28 plus c. This is nothing but integration of cos cube 7x with respect to x. Now we are going to talk about integration of secx and integration of cosecx. Integration of secx with respect to x equals to log of secx plus tan x. Of course the modulus is there. So log of modulus of secx plus tan x plus c. Similarly, integration of cosec x with respect to x equals to log of modulus of cosec x minus cot x. The terms inside the modulus can be trigonometrically simplified to get other expression for integration of sec x and for integration of cosec x. Let us simplify sec x plus tan x. Sec x can be written as 1 upon cos x and tan x can be written as sin x upon cos x. Here it can be written as 1 plus sin x upon cos x. 1 can be written as sin square x by 2 plus cos square x by 2 and sin x. The formula for sin x is nothing but 2 sin x by 2 dot cos x by 2. This is a trigonometrical formula. Sin x equals to 2 sin x by 2 dot cos x by 2. I am using that formula here. So it is 2 sin x by 2 dot cos x by 2 upon, here is a cos x is there, cos x can be written as cos square x by 2 minus sin square x by 2. It is a trigonometric formula. So that formula also I am using here, cos square x by 2 minus sin square x by 2. This is equals to, the numerator equals to a square b square plus 2ab. So this, that is a plus b whole square. So I am going to use the numerator a plus b whole square, that is sin x by 2 plus cos x by 2 whole square upon a square minus b square. Here a square minus b square equals to a plus b into a minus b. So that formula can be utilized to simplify the denominator. So I do get here cos x by 2 minus sin x by 2, a minus b into a plus b. So this is equivalent to, here is a square is there, so I can write it twice. And denominator as it is. This, sorry, this and this get cancelled. I do get here sin x by 2 plus cos x by 2 upon cos x by 2 minus sin x by 2. Now dividing both numerator and denominator by cos x by 2, I get here sin x by 2 plus cos x by 2. Dividing both numerator and denominator by cos x by 2, cos x by 2 minus sin x by 2 upon cos x by 2. This is equals to sin x by 2 upon cos x by 2 plus cos x by 2 upon cos x by 2 divided by cos x by 2 upon cos x by 2 minus sin x by 2 upon cos x by 2, cancellation now, this and this get cancelled, this and this get cancelled, and sin x by 2 upon cos x by 2, this is equals to tan x by 2. Sin x by 2 upon cos x by 2 equals to tan x by 2. So we use that formula, equals to tan x by 2 plus 1 upon 1 minus tan x by 2. This is equals to, this is a trigonometric identity, this is equals to tan of x by 2 plus pi by 4. Therefore, integration of sec x with respect to x also equals to log of tan of, here is a modulus, tan of x by 2 plus pi by 4 plus c. This is another form of integration of sec x. Similarly, cosec x minus cot x can be simplified as next step, 1 minus cos x can be written as 2 sin square x by 2, and sin x can be written as 2 sin x by 2 dot cos x by 2. This and this cut down, this and this cut down. I do get sin x by 2 upon cos x by 2 equals to tan x by 2. Therefore, integration of cosec x with respect to x is also given by log of modulus of tan x by 2 plus c. Thus, integration of sec x with respect to x also equals to log of modulus of tan of x by 2 plus pi by 4. Also, integration of cosec x with respect to x equals to log of modulus of tan x by 2 plus c. Let us do some problems on the basis of sec x and cosec x. Integration of sec 3x with respect to x. Here I did put 3x equals to k, then I got dx equivalent to dk by 3, then 1 by 3 taken out of the operation, 1 by 3 integration of sec k with respect to k. Now we are using the formula here, that is either or, that is a integration of sec k equals to 1 by 3 log of sec modulus of sec k plus tan k, or 1 by 3 log of modulus of tan of k by 2 plus pi by 4. But k is equal to 3x, so putting back into the equation, so we do get the integration of sec 3x. Integration of cosec 5x plus 6. Let 5x plus 6 equals to k dx equals to dk upon 5, I equals to integration of cosec k dk upon 5, 1 by 5 integration of cosec k dk. We can apply either of the two formulas I told you earlier. So let me apply the first formula, integration of cosec, that is log of cosec k minus cot k plus c, or 1 by 5 log of modulus of tan k by 2 plus c. Here k equals to 5x plus c. Putting back the value of k, 5x plus 6, putting here r 1 by 5 log of tan k nothing but 5x plus 6 plus c. This is required integration of cosec 5x plus 6. Now we will be studying integration of tan x and integration of cotx with respect to x. Integration of tan x with respect to x equals to log of modulus of secx plus c, and integration of cotx with respect to x equals to log of modulus of sin x plus c. Let us do some problems on the basis of integration of tan x and integration of cotx. Example, integration of tan of 5x with respect to x equals to how much? Step number 1, let 5x equals to k, differentiating with respect to x equals to dk by dx, 5 equals to dk by dx, therefore dx equals to dk upon 5. This is given problem is I as usual. Now I equals to tan 5x can be replaced by k and dx equivalent to dk upon 5. So 1 upon 5 outside, integration tan k with respect to k equals to 1 upon 5 log of modulus of sec k plus c. Back substitution, k value is equal to 5x, so sec of 5x plus c. Therefore integration of tan 5x with respect to x equals to 1 upon 5 log of modulus sec 5x plus c. Now integration of tan 12x plus 6 with respect to x equals to how much? Steps are as usual. Let 12x plus 6 equals to k. If your college teacher using shortcut, you can also use shortcut, but it is my aim that students should know each and every step. Therefore I am writing most of the steps here. I am not doing shortcut at all. But if you wish to skip some steps, you can. Now 12x plus 6 equals to k. Differentiation of 12x plus 6 with respect to x equals to dk by dx. Therefore 12 equals to dk by dx. Therefore dx equals to dk upon 12. Therefore integration I equals to, given problem is I, tan of 12x plus 6 can be replaced by k and dx can be replaced by dk upon 12. 1 upon 12 is outside. Integration of tan k with respect to k equals to 1 upon 12 log of modulus of sec k plus c. K value, putting back the k value, k is equal to, k equals to 12x plus 6. So putting that value here, 12x plus 6 modulus plus c. Therefore, integration of tan of 12x plus 6 with respect to x equals to 1 upon 12 log of modulus of sec 12x plus 6 modulus is over plus c. This is required answer of integration of tan of 12x plus 6. Now, integration of cot 3x with respect to x equals to how much? Let 3x is equal to k. We get I equals to 1 by 3 integration of cot k dk, and integration of cot k nothing but log of modulus of sin k plus c. K value is 3x plus c. Therefore, integration of cot 3x with respect to x equals to 1 by 3 log of modulus of sin 3x plus c. Now we will be talking about integration of sec square x. Integration of sec square x with respect to x equals to tan x plus c, and integration of cosec square x with respect to x equals to minus cot x plus c. Let us do problems on the basis of integration of sec square x and cosec square x. Now, integration of sec square 5x plus 6 with respect to x. Steps are as usual. 5x plus 6 equals to k. We do get dx equals to dk upon 5. Therefore, I equals to sec square k dk upon 5. 1 upon 5 taken outside, and sec square k integration is tan k. So, it becomes tan k upon 5. Putting back the value of k, that is 5x plus 6. Therefore, at the end we get integration of sec square 5x plus 6 with respect to x equals to tan of 5x plus 6 upon 5 plus c. Another example, integration of cosec square of 5x plus 6 with respect to x equals to how much? We put here 5x plus 6 equals to k. We get dx equals to dk upon 5. Therefore, integration I becomes integration of cosec square k and dx equivalent to dk upon 5. Therefore, integration becomes integration of cosec square k dk upon 5. Now, we take the 1 upon 5 outside. Integration cosec square k with respect to k equals to 1 upon 5 cosec square k integration minus cot k, back substitution 1 upon 5 minus cot 5x plus 6. Therefore, integration of cosec square of 5x plus 6 with respect to x equals to minus cot of 5x plus 6 upon 5 plus c. Now we'll see how to find out integration of tan square x with respect to x. There is no direct formula for integration of tan square x. We first convert to some other form by using trigonometric identity, that is 1 plus tan square x equals to sec square x. Therefore, tan square x equals to sec square x minus 1. Therefore, I equals to, in place of tan square x, we can write sec square x minus 1 with respect to x. This is equals to integration of sec square x dx minus integration of 1 dx. Integration of sec square x nothing but tan x, and integration of 1 is nothing but x. Therefore, integration of tan square x with respect to x equals to tan x minus x plus c. Now integration of cot square x with respect to x equals to how much? Here also there is no direct formula. We require trigonometrical conversion. We already know that 1 plus cot square x equals to cosec square x. Therefore, cot square x equals to cosec square x minus 1. Therefore, integration I equals to, in place of cot square x, you can write cosec square x minus 1 with respect to x equals to integration of cosec square x dx minus integration of 1 dx. Integration of cosec square x nothing but cot x, and integration of 1 is nothing but x. Therefore, final answer, integration of cot square x with respect to x equals to minus cot x minus x plus c. At the end, let us see the new two formulae. After this, we will be ending this session. And here is a integration of secx into tan x with respect to x equals to sec x plus c, and integration of cosec x into cot x with respect to x equals to minus cosec x plus c. Let us do some problems on the basis of this formulae. Example, integration of sec 5x tan 5x with respect to x equals to how much? Here, as usual, 5x equals to k, then we get I equals to 1 upon 5 integration of sec k into tan k with respect to k. I equals to 1 upon 5 sec k plus c. Putting back the value of k, sec 5x plus 6. Therefore, integration of sec 5x tan 5x with respect to x equals to sec 5x upon 5 plus c. Another example, integration of cosec 5x cot 5x with respect to x, 5x equals to k. One upon 5 outside. Now applying formula of integration, that is integration of cosec k into cot k is equal to minus cosec k putting back the value of k plus c. Therefore, integration of cosec 5x cot 5x dx equals to minus cosec 5x upon 5 plus c.